explore working with relational databases with Python through working with SQLite. So SQLite has a lot of advantages for using it. A SQLite database is just a file, so we don't need to mess with complex administration, setting up a server, getting port access, etc. SQLite is available on almost any computing platform you can think of. It's compact, it has a very small memory footprint, it has liberal licensing, it's very reliable, it's very well tested code. It's just kind of used everywhere for these lightweight applications. So Android, iOS, I know about Android, I imagine iOS. SQLite is sitting behind many applications that you're using every day. And it's been integrated directly into Python since Python version 2.5. It has its limitations. It's slower, particularly for complex queries, than other databases. It has no foreign key constraints, which is just a way of checking to make sure that relationships that we define exist the way that we define them, and it doesn't have any concurrency. So first off, the first thing we're going to need to do to interact with the database is to connect to it via a connect command. So here I'm importing SQLite. I have put a database into named SeinfeldFood.SQLite into the repository for the class, and I make a connection by the SQLite.connect function, and it takes as an argument a path to a file. If a file doesn't exist, it will create a database for it. All right, so we have a connection. There's lots of things that connection can do. So if I do my .tab to see what kind of things we have various errors that are defined for it. We can close, we can commit the changes. This will be important because the database doesn't record the actual changes we've done until we commit them. We have an execute many, which are shortcuts for things that we would normally do with a cursor. And we have this function for creating a cursor. And so we can get the help on that. And returns a cursor for the connection. That's not too useful. All right, but that cursor is going to be very important because that cursor is how we're going to interact with our database. And just kind of aside, I don't know if this logically fits here, we can create databases in memory, which is particularly useful for just exploration, and we do that by connecting to a database named :memory:. So here I create another cursor connection. Okay, so the cursors are where we're going to use to execute SQL queries and to examine the results. So if I create my cursor, and that's just because what I wanted to do here was just do the tab explorer. Okay, come on. There are a variety of things that this cursor can do, the most important of which are execute many, fetch all, fetch many, fetch none. Last row ID will return the primary key for the last row in the table. Lots of other kind of functionality that we can learn about. All right, so we can get the help method on any of these functions or methods that the cursor object has. So just kind of skipping through these, you can look at those on your own. So the first thing the last notebook we said, it all revolves around tables, so we need to learn how to create tables. So here I have a link to the SQLite documentation on the create table statement. But the basic syntax is we create table, we provide a table name, and then we provide a column name, and this could be a comma-separated pair of tuples, column name, and what type of data is going to be in that column. So we have memory, where I'm connecting to a cursor in memory, a database in memory, creating the cursor for it. So here I'm going to create a table named runArgs, and it's going to have 3 columns named run date, label, args, and these all have data type of text. And that runs, and it's all happy. Now if I try to create a table that already exists, I get an error. You see I get a operational error, table run args already exist. So SQL lets me insert a conditional statement into the create table, so I can say create table if not exists run args. And I run this and everything's fine. Okay. Of course I could also use an exception in Python, but why not stick with what SQL provides for us? Okay, when we're creating tables, if you've read through the tutorial, you'll learn that we want to split our data across tables to avoid redundancy and to ensure data consistency. And so foreign keys are how we relate that this row in this table relates to this row in another table. And so I'll have some examples here of how we do it. So the syntax is I'm going to take a column name that I've already declared in my table, and I'm going to declare that to be a foreign key, and then it references some other table in my database, and some particular column in that other table. So here's an example where I'm declaring a foreign key. The column result is my foreign key. It references this other table, PyContext NLP underscore results, and it references the row ID column in that table. So here, this is just pulled from some of my other code. I'm creating a variety of tables. So I'm creating a table run args, class schema, and here I'm creating a table that has foreign keys. So it's a table named PyContext NLP results, and it has the following columns: report number, run arg, schema, target category, classification, most positive target. And these are of type int, text, int. And then what I'm saying is, well, this column run args that I declared, it's a foreign key, and it references the table run args that I created up here, and it references the column row ID. I'll make a comment about this in a second. Similarly, schema is also a foreign key, and it references the table class schema, and again it references the column in class schema named row ID. And similarly here. We didn't, if you see when we created these tables, there's no column named row ID. Now what row ID is every table has to have a primary key, and the primary key is going to be this unique identifier that's going to be a unique value that identifies any particular row in the table. And if we didn't explicitly provide one, then SQLite creates a column named row ID and assigns that to be the primary key. All right, and I think I actually say that again later. So we create tables. We said in the last notebook, now we need to insert data into it, and we do that with insert into. We provide the table that we're going to insert into, in this case run args. We say which columns we're going to insert into. In this case, we're going to insert into the columns run data, label, and args. We're going to insert in the values. And remember that SQLite, its parameter style is a question mark, so we have these 3 question marks, and we're going to have the cursor insert into those 3 question marks, the runtime, result label, and outstring values, and then execute the SQL statement. Okay, well, what do the various selects look like? Well, we have select star from run arg. So star asterisk selects all the columns in the table. Here I'm doing select row ID and label from run args. So it's only selecting these 2 columns from the table. Here I'm doing select row ID, so I'm just selecting a single column from run args, but I'm doing where run date equals, again, some value that's going to be inserted in from the variable runtime. So I have a question. I'm only going to return the row ID values for rows where run date equals the value stored in runtime. Okay, any changes I've made to the database aren't committed until I execute the commit method of the connection object. And just again to emphasize, never use Python string formatting directly to generate a SQL script. You always want to have the values inserted in by the execute command, and this is because the direct generation is a security risk, and the execute or execute many have checks to make sure that you're not injecting malicious code into your database. All right. Just going to delete that. I don't know why that's there. Okay, so we can create our query beforehand. This is what I don't want to do. This is an example of doing what I don't want to do. Okay, so we created a table. We inserted values in the table. Now we need to be able to pull data out of the tables, and we do that with fetch statements, fetch methods of the cursor. So we can fetch one, which just gets the next result, fetch all results that match our query, and fetch many, where we specify how many we want to return. So here I'm creating another database in memory. I'm going to create a table of class participants. I'm going to insert into the class participants various values. So I'm going to say Brian, role of a teacher. So you see I have a name and a role. And then I have other people that I've got my list of 2 tuples. And then I'm going to use execute many to insert them into the database. Okay, so now I'm going to insert into class participants a single person, so I'm only providing their name, I'm not providing a role. It lets me do that. And now what I'm going to do is so I've created my table, I've inserted my values, now I'm going to use select to get data back. I'm going to select all my columns from class participants, and then I'm going to, what fetch all does is it returns a list. At least it did in Python 2.7, maybe it's an iterator in Python 3. But I'm going to loop over all of my results and print them out. So you can see with Homer, where I didn't provide a role, SQLite provides the value none. Okay, so here's a table of what different Python types map to different SQLite types. So an int is an integer, a long is an integer, a float is a real, and so on. All right, so what if we have a class? So this is like I'm inserting strings, I'm inserting numbers. If I have a class of my own and I want to insert into a database, then I need to come up with a way of mapping that class into something that can be stored in the database. And so typically convert an object to a string. And so I can define a special magic method, special/magic method, _conform, and then SQLite will be able to call this magic method to do the conversion of the object to a storable data type automatically. So here, and this is pulled just straight from the SQLite 3 documentation, I define a class point, consists of an x and a y value, and I have my string, my representation, and I define this conform function. And so I ask some protocols coming in. If it's a SQLite prepare protocol, then I take my x and y values and I insert them into a string where they're separated by a semicolon. So again, I can create a database. I can make a cursor. I create an instance of my class point. I insert this in values 4 and 3.2. I insert that with an execute statement. And then when I select one, I get what that object back was. Okay, instead of having a class method, I can define a function that does that conversion for me, and I can register that function with SQLite. So I say if I have a type point, then I'm going to use the adapt point adapter. And kind of funky. I'm just kind of confused here. So I guess I'm selecting something that I haven't inserted, but Python is doing the, I forgot to have my mail turned off before I started recording the video. But you see that it's calling this function for me. Well, actually, what if I separate that just to verify that it's using this adapted method, not the conform special, the adapt point function instead of the conform method to do the conversion, because I got a comma there. All right, so I actually have this in the next notebook, so we'll stop this notebook right